So here we have an example. There's a researcher, and he's studying. He's interested if there's a relationship between churches and not violent crime, but churches and crimes in general. So he takes a sample of 7 small towns, and then he records how many towns the churches have, and the average number of crimes that are committed per week in the town. And so here's the data. And so this researcher is kind of thinking that maybe churches help crimes. Maybe crimes will go down. And so he gets this data to see if perhaps there's a correlation between the two. And he's kind of surprised, and we'll see why that is. But first, I'm going to have you calculate R for this to see whether or not there's a correlation, whether it's positive or negative, and how strong that correlation is. So go ahead and press pause, calculate the correlation, and then you can resume the video and see how you did. Okay, so let's go ahead and see how you did. So the number of churches, those are your X's. The number of crimes are the Y. So what I need to do is extend this table out a little bit to include X squared, Y squared, and X times Y. So these are just the square of the X values. Easy enough. I got 1, 9, 16. This will be 49, 81, 100, and 121. And my Y squares, this would be 1, 9, 4, 25, 36, 64, and 100. And then this is my my X times Y. So 1 times 1 is 1, 3 times 3 is 9, 4 times 2 is 8, 7 times 5 is 35, 9 times 6 is 54, 10 times 8 is 80, and 11 times 10 would be 110. Okay, so now I got to get these sums, which I haven't done yet, so I'm going to do on my calculator. 1 plus 3 plus 4 plus 7 plus 9 plus 10 plus 11. So I get 45 here. And the crimes, let's see, 1 plus 3 plus 2 plus 5 plus 6 plus 8 plus 10. And I'm going to get 35 for that. And X squared here. So 1 plus 9 plus 16 plus 49 plus 81 plus 100 plus 121. That's 377. And so Y squares 1 plus 9 plus 4 plus 25 plus 36 plus 64 plus 100. I get 239 for that. And then finally, the sum of X times Y. 1 plus 9 plus 8 plus 35 plus 54 plus 80 plus 110. And I get 297 for that. Okay, so let's calculate. These are the sums. I'm not going to write them all out, but this is the sum of x, the sum of y, sum of x squared, sum of y squared, sum of x times y. So let me write out my SS's. So SSx would be the sum of x squared, 377, minus the sum of x, okay, that quantity squared, over, there's 7 rows in my table, or 7 ordered pairs, over 7. Okay, so let's see what we get. So I got 377 minus 45 squared divided by 7. And this doesn't necessarily come out evenly, so I'm going to go to at least 4 decimal places. I'm going to go to one more than what I'm going to round my answer to. So it would look like that. And then SSY. This is going to be the sum of y squared, 239, minus the sum of y, that quantity squared, over 7. This is approximately. So this one, let's see what we get. 239 minus 35 squared divided by 7. And that actually comes out real nice, 64. And then finally, SSXY. Here we got the sum of x times y, so 297, minus the sum of x, which is 45, and the sum of y, which is 35, divided by 7. So 297 minus 45 times 35 divided by 7. And again, the number turns out pretty nice, 72. So notice that both of these are positive. And this one is positive as well, which means this data has a positive correlation, and it does. As these increase, the other one also seems to be increasing. So now we can calculate R. And so R is going to be, the 72 is going to go on top, divided by, and then I'm going to have the square root of that 87.7143 times 64. Okay, so let's see what we get. So 72 divided by the square root, and then in parentheses 87.7143 times 64, and I get approximately 0.961 when I round to 3 decimal places. That is a very, very strong positive correlation. So let me actually do the table here to see if that makes sense. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And maybe this one I'll go up by 2s. 2, 4, 6, 8, 10. And so 1, 1 would be like right here. 3, 3 would be right here. 4, 2 would be down here. 7, 5 would be like right here. 9, 6 right here. 10, 8 is like right there. And then 11, 10 is right here. And so yes, indeed, this does seem like a very strong positive correlation. So that worked out good there. So to finish off here, let me just say I chose this example, churches and crimes, to make one final point here. So let's say this researcher found this data and realized there's a very strong positive correlation. And he was very surprised because he thought maybe churches would help crimes, right? Not cause crimes, but clearly the data says the more churches, the more crimes. And so he comes to the conclusion, churches cause crime. And would you agree with him? And of course the answer is no, that's not true. Churches do not cause crimes. And the reason this has a positive correlation is clearly what is the reason? Why do they go up together? And the answer to that is the bigger the town, the more churches, but also the more crimes. So as the town increases in size, both variables are going to increase together. And so yes, indeed, there is a relationship, and that relationship is that there's a positive correlation between the variables, but just because there's a positive correlation, the correlation doesn't prove causation, right? So correlation does not prove cause and effect. So if you want to show cause and effect, you would need to have an experimental study. If you remember back to chapter 1, a correlation study can only show that there's some sort of relationship, and it could be that it's a cause and effect relationship, but it doesn't have to be. There's lots of reasons for variables to be correlated with one another. Okay? So there's a relationship, not a cause and effect relationship in this case, because clearly the relationship is that both of them increase as the cities get larger. Okay? So, that's how to calculate R, and that is a big part of chapter 10. In fact, I would say that is the biggest part. That's probably the most difficult thing. But there are some other things in chapter 10, and they include, there's a hypothesis test for calculating or for using the R to determine whether or not a correlation exists in the entire population. So this is just a sample of 7 cities. So what about the entire population? Is there a correlation? Does this give you enough evidence for a correlation in the entire population of small cities? Okay, that's kind of the idea. And then there's going to be this idea of the regression line, which is a line that fits the data the best. And if you have enough evidence to conclude a correlation in the population, then that regression line may be useful. We're going to learn how to find that regression line and use it. And then we're going to be done with chapter 10. So those videos will be coming up.